So welcome today to I'm back to your screen again with tricky quarters. So we are going to look at the first one, that is the 8. So we are given a data set and it's a single data. So you are being asked to calculate for quartiles. So you know quartile. So the first one is what? Our Q0. Okay. The Q0, just as we know, Q0 simply means what? The is the least value of the data set. Okay. And with this one, because we have a single data, the Q0 becomes what? 8. Okay. Then our Q4, which is the maximum value of the data set, will also become what? 8. Okay. Now Q2, which is the median, will also be what? 8. Q1, Q3. Q1 is actually the median of the first data set, okay, or of the first data. So you realize that this one, the first part of the data, still falls within the what? 8. So this one is going to be 8. Q3 will also be what? 8. Now, in case you are being asked to calculate for the interquartile range, okay, you know, interquartile range is equal to what? Q3 minus what? Minus Q1. That means that this one you are going to get 8 minus what? 8, and that will be what? 0. Okay. Now, if you are being asked to calculate for the outliers, you know the outliers, that means that you have to get your lower bound and what? Upper bound. And this is the formula for lower bound. Okay. So this is the formula for lower bound. So the lower bound is Q1 minus 1.5 times interquartile what? So let me write it well here for you so that you see. So lower bound is equal to what? Q1 minus 1.5 times interquartile range. Okay. So our Q1 is what? 8 minus what? 1.5. Then interquartile range is what? 0. Okay. So you know mathematics, that means that you're going to get what? 8. Okay. Now the upper bound. So with the upper bound is going to be what? Q3 plus 1.5 times interquartile range. Okay. Now that's going to be 8 plus 1.5 times what? 0. And that one will also give us what? 8. Okay. So now, if you look at the data set, it means that there is no what? Outlier. Okay. Now, if we want to draw it on the box plot, this is how it will be. So this is how it will be. So this is the median, that's the Q2, and then our Q2 is what? Is 8. Okay. And you know this is our maximum value, and then so the maximum value is what? 8. Then sorry, this is the least value, 8. Maximum value is also 8. Our Q1 is 8, Q3 is also 8. Okay, and with the interquartile range, it is what? 0. So this is how you what? Present it. All right. Now let's look at when you are given a data set of 1, 2, 3, 4. 4 data sets. Let's also look at this, how you go about it. Okay. I believe you are actually understanding it. So if you have any question, you can put it at the comment section and we'll come around to respond to that. All right, so let's look at this data. You have been given 4, 8, 10, 20. All right, okay, already the data has been arranged. So now our Q0, which is the least value of the data set, is what? 4. Our Q4 is the highest value of the data set, is what? 20. Our Q2, that's the median. So this one, because the data is an even data, we will have what? 2 numbers at the middle. So that's going to be, the median is going to be 8 plus 10 divided by 2. And that will be giving us what? 18 over 2, which is what? 9. Okay. Now, for us to get our Q1, so with the Q1, when we are giving an even number, now you strike it this way. Okay. So this part becomes your first half of the data. Okay, and this side to become to your second half of the data. So Q1 simply means what? The median of the first half of the data. And with this one, because we have two numbers, it means that the median is going to be what? 4 plus 8 divided by 2. And that one will be giving us what? 12 over 2, which is what? 6. Okay. Now we come to the Q3, which is what? The median of the second half of the data. And that one too is going to give us what? 10 plus 20 divided by 2. And that's going to be 30 divided by 2, which will be what? 15. Okay. Now, once we have gotten our Q1 and Q3, it means that we can solve for interquartile range. And interquartile range is what? Interquartile range is what? Q3 minus Q1. That means that, you know, the Q3 is what? 15 minus Q1, which is what? 6. So our interquartile range will be what? 9. Okay. Now, since we have interquartile range, it means that we can move ahead to solve for our lower bound and upper bound in order to get our in order to determine whether there will be an outlier or not. So let me clean this side. Okay. So that we solve it. Okay. So let me maintain it up to here. So now lower bound. So the lower bound is what? Q1 minus 1.5 times interquartile range. The Q1 is what? 6. Okay. So 6 minus 1.5 times the interquartile range is what? Is 9. So times what? 9. And that one is going to give us what? What? Minus 7.5. Okay. Now we can solve for the upper bound. Okay. The upper bound. So the upper bound is what? Q3 plus 1.5 times interquartile range. In fact, you have to take, or you must be careful with the lower bound and upper bound. One is minus and what? One is plus. Most of the time, students do mix it up. Okay. So this one, the Q3, we had what? 15. So 15 plus 1.5 times 9. And the answer is going to give us what? 28.5. Okay. Now, if you look at the data, we have our lower bound being what? 7.5. And then our upper bound being what? Okay, 20. All right. So our upper bound being what? 28.5. Are you getting that way? So now we want to look at it whether there's an outlier. You see, this is the data set. Okay. If you look at it carefully, you could realize that all the data set falls within what? It falls within the 7.5 and what? And 28.5. Okay. So it means that if you look at this side, there's no value that is what? Smaller than what? The lower bound, which is the negative 7.5. And also there's no value that is what? Higher than what? The upper bound, which is what? 28.5. Okay, so the lower bound and upper bound is like this, it's like a boundary. I get that way. So what you have to write is that you say there is no outlier in the data set. That one alone what carries what? Max. I get that way. So now when we are done, we can just we can present it on the board plot. Okay. I don't know where to write it. Anyway, let me try and clean this side. Okay. So you let me draw it small here. Okay. Yeah. So so this one, if your examiner asks you to present it on the board plot, you just apply the principle that I used to do the first one. Okay. So let's look at when you are given 3 data sets. Okay. Let's look at that one quickly. Okay. So now the example 3. So that the example 3, our numbers, our data sets. So let's arrange it. So in arranging it, we start from 6, 7, and what? 15. So this one you have been given what? 3 numbers for the data set. Okay. Now your Q. So this is an odd data, okay. Your Q0, which is the least value of the data set, is what? 6. Your Q4, which is the maximum value of the data set, is what? 15. Then your Q2, which is the median, is what? 7. Okay. Now Q1 simply means what? The median of the first half of the data. And with this one, this part becomes what? The first part. This one becomes what? The second part of the data. So our first part of the data, the median of the first part of the data becomes, it is what we do with the 6. So it's what? 6. Then with the Q3, the median of the second half of the data to fall within the 15, which is what? 15. So we can solve for what? Interquartile range, which is Q3 minus Q1. And that's going to give us the Q3 is what? 15 minus the Q1, which is what? 6. And this one is going to give us what? 9. Okay. So now we can solve for what? Our lower bound. Let me clean some parts so that you can follow. So let's solve for the lower bound. Q1 minus what? 1.5 times interquartile what? Range. Do you get it? So that's going to, our Q1 is what? 6 minus 1.5 times the interquartile range is what? 9. Okay. So this one is going to give us what? Negative what? So if you see that, in fact, it's like this one, the answers we'll be getting will not be far from the one we solved here. Okay. Then the upper bound is Q3 plus 1.5 times interquartile range, which is what? 9. And that one is going to give us what? Anyway, so 15 plus 1.5 times 9. And that will be giving us, so those are the calculator. What? 28.5. Yeah, I said it. 28.5. Okay. So it means that if you look at the data set, there's no number that is what? Smaller than the 7.5. Okay. And negative 7.5. This data, there's no number that is smaller than negative 7.5. And in other words, there's no number that is what? Bigger than what? The 28.5. That means that there is what? No what? Outlier. Okay. This is Nelson's way of writing outlier.
Okay. My name is Joseph and I'm here to take you through tricky quartiles. So with my first example, we are having a single value, which is 20. So when you are asked to calculate for the quartiles for a single value like 20, all the quartiles will be the same except for the interquartile range. That one will be 0 because the lower value here is 20, the higher value here is 20. That's the Q3 is 20 and the Q1 is also 20. You subtract, you get 0. Okay, so we are going to have our Q0 to be 20, our Q1 to be 20, our Q2, which is the median, also to be 20, our Q3 also to be 20, but our interquartile range, which is the you have upper then lower bound. Okay, upper bound and lower bound. The lower bound will be equal to Q1 minus 1.5 times the quartile range, yeah. And the upper bound Q3 plus 1.5 times the interquartile range. Okay. So I'm going over the first example. We are working with a single value and it is 20. So when we are asked to calculate for the quartiles for a single value, all the quartiles will be 20 except for the interquartile range. That will be 0. So here we have our lower value to be 20, our lower quartile also to be 20, then our median to be 20, our upper quartile, and then the fourth quartile to be also be 20. By the interquartile range, the Q3 minus the Q1 gives us 0 because 20 minus 20 is 0. Then the upper bound, we have the formula to be Q3 plus 1.5 times the interquartile range. And the lower bounds, we have Q1 minus 1.5 times the interquartile range. So For the upper bound, I'm going to have 20 plus 1.5 times 0. And we all know that when it comes to the rules in mathematics, any number times 0 is 0. So 1.5 times 0 is 0. So the answer still remains 20. The same applies to the lower bound. Okay, so here our second example has two values, which is 16 and 14. So if you are given an example and it contains two values, this is how to solve for the quartiles. Here we are going to have our lower quartile. So arrange the data first. So here our data will be 4, then 16. So you have our lower value, which is the Q0 to be 4. Then our upper value, which is the K4, also to be 16. Now, our K1 here, to find for our K1 here, since the data here is even, you are going to divide the data into 2. So I'm going to have 4 at one side and 16 at the other side. Now, here K1 is 4, then our K3 will also be 16. So our K1 is 4, then our K3 is also 16. But our Q2 here, to find for our Q2 here, which is the same as the median, we add the 4 to the 16, then we divide by 2. So you get 20 divided by 2, giving us 10. Okay. Now let's go to our interquartile range. In calculating for interquartile range, we know the formula is K03 minus K1. Here our K03 is 16, then our K1 is 4. So we get 12 to be our interquartile range. And in calculating for the upper bound, we know the formula to be K03 plus 1.5 times the interquartile range. And in calculating for our lower bound, we know the formula to be K01 minus 1.5 times the interquartile range. Let's solve for our upper band, then we also solve for our lower band. So the upper band, we know our K03 to be 16. Then we add it to 1.5 multiplied by our interquartile range, which is 10. So now we get an answer of what? 31. Then let's go to the lower band. Our lower band, we have our K1 to be 4. Then minus 1.5 times our quartile range, which is what? 10. And here you know our answer to what? Minus what? 11. So in determining your upper band and your lower band, here is not the answer. But you go to the data set and you check out the values which falls outside the lower bound and the values which falls outside the upper bound. That will be our lower bound and what? Our upper bound values. So here we got our upper band to be 31. So checking the data set, the highest value in it is 16. That means we don't have any value in the data set that falls outside 31. So we have no upper band. Then checking the data, the lower band we got minus 11. You check the data, there's no value here that is lower than the minus 11. So here you conclude that therefore there is no band or outlier. There is no outlier. Okay. Yeah, I'm going over. When we are given two values for you to find for the quartiles, first of all, the procedure is you arrange the data. You arrange it in ascending order. So here we have 4 and 16. So our 4 comes first, then followed by our 16. Then in determining the Q0, here our Q0 is 4. Then our Q4, which is the upper value, is 16. Our Q1 is the first set. We check the first set of the data, then we determine the middle value. Here we have only one value here, which is 4. So our Q1 is 4. Then our Q3 is also 16. Okay. So in determining our Q2, you know that Q2 is the same as the median. And we have only two values here. So we find for the average of these values, which is we add 4 to the 16. getting 20, we divide by 2, then we get 10. To find for your quartile range, we subtract the KO1 from the KO3. From the question, we have our KO3 to be 16, then our KO1 to be 4. So we got 12. In calculating for the upper bound, we use the formula of KO3 plus 1.5 times the interquartile range. So our KO3 is 16 plus 1.5, then the quartile range is 10. Then we had 31. Then for our lower band, our KO1 is 4 minus the 1.5 times the quartile range, which is 10. Then we have minus 11. Then I said, this is not the answer. You come to the data set and you check out for the value that falls outside the lower band or the upper band. And we have only two values here. Then for the upper band, we have 31. The values here is not up to 31. We don't have any value which is greater than 31 here. So that means there's no upper band. And for the lower band, we have minus 11. We have 4 and 16, and none of them is lower than the minus 11 here. So therefore, you conclude that from the question, there is no outline.